Virtual private cloud, building your network foundation. Everybody has their niche in the IT realm, and mine is network technology, which really freaked me out when I got into Amazon Web Services. I was sitting next to a guy, we spun up our first EC2 instance in what's now called EC2 Classic, but it wasn't called that back then. And we're getting up and running. He goes, up, there you go, see, it's got a public IP address. I was like, whoa, public IP address straight into the server, and that's yours? Yeah. I go, well, what's the private IP address? And he goes, doesn't really matter. It's just all dynamic, managed by AWS. Like, what? Like saying that to a network guy is like, are you speaking the same language as me? Doesn't really matter. Dynamic address assigned to a server? What? What are you talking about? This doesn't make sense to me. And it's almost like the further down the rabbit hole you go, it's like, this giant subnet mask and no control. It's just all just happens. So it was a pleasant surprise coming to find out that there is VPC, Amazon Virtual Private Cloud. That's what we're going to do in this nugget. It's going to be focused on what is VPC. Give me the big picture. What can you do with it? We'll walk through the initial setup of VPC. And then I would say, for me, being the network guy, the most valuable piece was to really understand kind of a view behind the scenes of here's how the routing of a VPC works. Here is your Do I Know This Already slide. So hit the pause button, read through the 3 questions. If you already know the answers, you probably don't have to go through the information contained in this nugget. If you don't know the answers, let's get started. Well, let's start off with the question, what is VPC? And I don't know why. When I thought of that question, an email forward comparing Windows and Mac to airplanes popped into my head. It said, if you're flying on a Mac airplane, your plane always gets from point A to point B. Everybody's buckled in into neat little rows. But if anybody tries to stand up and say, go to the bathroom mid-flight, the flight attendant will walk up and say, sir, sit down. You're in our plane right now. We'll tell you when to go to the bathroom. Whereas in a Windows plane, you can go to the bathroom anytime you want. But at any given point, without warning, the wings of the plane could fall off and the plane plummet to the earth with everybody screaming. That's terrible, but at the same time, it kind of encapsulates the difference between VPC and what's called now EC2 Classic. The default mode for your servers in the clouds, your EC2 instances, was EC2 Classic until a few months back. Essentially, that is where AWS is in complete control. You spin up a server, you get it running, they give you a dynamic private IP address, throw a dynamic public DNS mapping, so you get a public IP address, but it's all, again, controlled behind the scenes. You can use elastic IP addresses if you want some level of control, but for the most part, almost everything is controlled by AWS, whereas VPC puts the control in your hands, gives you more security capabilities, gives you more control over the IP addresses and the subnets and how the routing works. But anytime more control is put in the hands of an administrator, there's more chance for error. So big picture, we moved to AWS VPC because we want more control over the network environment. But just like Spider-Man, with great power comes great responsibility. So what does control mean? Control means things stick around here longer. It's not as dynamic, ebb and flow-ish as the EC2 Classic feel. You can have multiple IP addresses. You can have static IP addresses in this environment. Matter of fact, you can even create elastic network interface cards to where you can detach the network interface from the instance itself. So an instance can go down and you reattach the network card of that instance to another machine, allowing it to have the same IP address and same MAC address as before. You get a VLAN-like configuration, which gives you the ability to segment within AWS your different devices. So I can have the web servers segmented from the database servers and segmented from the accounting servers or whatever else we have running up there. And whenever I say segment, that bleeds right into this world, security, inbound and outbound filtering. In the EC2 Classic world, there is no outbound filtering. You only get that in the VPC realm, and you can do so with 2 methods now. Security groups, which apply to the instance itself, the EC2 machine, or network access control lists, which apply to the subnet itself. So I can filter kind of everything on an IP address basis coming in or going out of that subnet. You also get single tenant hardware options. This is the only place where you can get your own server in the AWS world. You'll pay for it. You'll pay dearly. But at the same time, it's your hardware. You don't have that noisy neighbor problem where somebody's running all these other instances that start slamming the machine that you're using, causing your instance to suffer. In the single tenant world, you can say, I want that server, and you manage it and all the machines on it in its entirety. Finally, VPC is your key to the VPN configuration world, allowing you to link your off-site network, maybe your business, your corporate offices, or maybe you have your own data center. Maybe you've got a little data center where you run your own off-site storage or something like that. Well, VPC allows you to create a bolted-up VPN configuration between the two. All right, I think we've talked enough about it. Let's set one up. I'm going to go to Amazon Web Services and first off draw your attention to the region that I'm in, North Virginia. The VPC is specific to the region, meaning when I create the VPC, which is really just a big subnet, it's going to tie directly to, in this case, North Virginia. It does not bleed between regions. However, it does bleed between all of the availability zones or data centers within a region. Let me come back to the slide and show you something real quick. VPC, as defined by Amazon, is kind of what I'll call the master subnet that you can break apart. It must be between a /16 and /28. So that'd be, for instance, a /16 would be 172.16.0.0/16. That means essentially that the first two octets, it's equivalent to 255.255.0.0, first two octets of your IP address really equals the network ID. That's the master subnet that you create, and that goes for the entire region. So I've got my region right here of Virginia, right? And then inside of there, I can break apart my subnets of that VPC and apply them to the availability zones, the data centers within that region. Remember, every region that Amazon has at least 2 data centers within it. Hang on, let me just pull my drawing above the picture there. There we go. Has at least 2 availability zones in it, and that's where I can break apart my subnets and say, okay, well, 172.16.1.0/24. Now, you don't have to use the /24, but that's probably the subnet mask that most people are familiar with. It's the 255.255.255.0. So essentially gives you 254 IP addresses in a subnet that you're able to use. And I think when you use it in Amazon Web Services, they give you 251 usable IP addresses because they use some for the networking magic that they do behind the scenes. But these subnets are what you apply to the individual availability zones. Did you follow? Okay, so let's go back over here. We can, in the VPC world, set this up manually. I can go into your VPC and create the VPC and say, okay, the name of this will be, Virginia. Right, and the CIDR block will be 172.16. It doesn't have to be 1. It could be 10.5.0. It could be anything. But essentially, I can go in and create the master subnet. But I'm telling you, it's actually a lot easier, at least to just wing out an initial configuration if you use their wizard. In this nugget, I'm going to walk you through the wizard. In another nugget in this series, I'm going to break down the individual elements of the VPC, kind of get into the nitty-gritty detail, if you will, of it. So I'm going to click on Start VPC Wizard. And you notice, the network guy in me cringes when I see this selection. This was written by a non-network person. Essentially, when you create a VPC configuration, they give you 4 options. A VPC with a single public subnet, a private and public subnet, and then they give you the same options essentially with a VPN attached to it, to where you can bring in an outside data center, right, or outside connection into the VPC. I want to talk about the wording that they use. If I were to create VPC, and who am I, right? But if I were to create it, I would have called it VPC with a single subnet, because this has caused so much confusion with people until now. Matter of fact, when you first create the VPC, you create a circle, a blob, a subnet. I say, okay, this is going to be 172.16.1.0, and I put my instances in there. There actually is no public access for those devices that are in there. They are in their own little private subnet. Not public, private, and then we can link them up to the internet through an internet gateway. See some of these terms starting to come out. Internet gateway allows us to link them up, but the only way they actually get there is by us assigning elastic IPs to them. meaning public IP addresses that I manually map into those instances, the EC2 instances, running inside of my VPC. So when I see somebody get confused on this, I totally understand why. VPC with a single public subnet, it's not a public subnet at all until you make it one. What Amazon's trying to convey by saying this is essentially, we can run you through a wizard, it'll have one subnet. Or you can choose the option of public and private subnet, where you've got two of them, which I'll explain this in just a second, and you got two subnets. But the fact is, you and I can go into VPC and create 1,000 subnets if we wanted to and apply them all over the place. They just said, you know what, this is a wizard. It is a wizard. It is something to just get you started. It's not meant to be the cumulative everything with this. So honestly, every single time I run through this wizard, I only do this because then I just go in and manually tweak everything how I want it after that. But before I do, I want to show you this. What is this design? The public and private subnet. Well, what they're meaning by this is that you essentially have one subnet which you intend to expose to the internet. Again, this is your intention, is that you would have a public subnet. This might be your web servers or something like that. Let me get my marker on the screen here. This might be your web servers that are public facing and mapped to elastic IP addresses that are accessible on the internet, right? Then behind there, we've got another subnet that we use for our database servers. Right? And we set up rules to where the web servers can access database servers only on specific port numbers, MySQL port numbers or whatever ports you allow through to there. But you might still want these guys to have internet access. How do you do it securely? Right? Maybe you just want the database servers to have internet access so they can download whatever, Windows updates or Linux, Ubuntu updates are necessary, or download packages. I mean, you can't live anymore in the IT world without being connected to the internet. So they do so through a NAT instance. All this is really is an EC2 instance that Amazon gives you that automatically runs NAT for you. Right? You assign a public IP address from this subnet right here, and then you assign your routing table, which. Wait a second. Routing table. I was going to flip back to the other slide. I'll show that in a second. Routing table of the private subnet that says send all of your internet traffic through the NAT instance and then out to here. So essentially, the only one that ever gets exposed to the internet is this NAT instance. It acts as kind of another level of firewall to all your database servers behind the scenes. Does that make sense? That's why they have the multiple options. Okay, so I'm going to click on select for the single public subnet, and you notice right up front it's like, hey, got my recommendation. I don't like Amazon's recommendation, by the way, but they always throw the 10 subnet at you. They're like, here, have everything starting with 10.0.0.0/16. That's, again, going back here, the master subnet has to be between a /16 and a /28. I'm sure if you email Amazon and say, I need something bigger and here's why, they would let you do it, but this is their default. So I don't like just doing 10.0.0.0. It's kind of, I don't know, creepy to me, or it's just too zero-ish. So I'm going to do 172. Let's just use 16.0.0. I gave that example a couple times. So this is the master subnet, which again applies to the what? Region as a whole. The whole region, all the data centers in there can get things from that subnet. What am I going to call this? I don't know why it just popped in my head. I'm in the Virginia region. Counting Crows back in, that'd be, I was college age-ish. Had a song called Meet Virginia. Meet Virginia. So that's what we'll name this VPC. It's just a name, right? Then it says, okay, this is confusing. I wish they would not call it the public subnet. They should call it the first subnet. And it's giving me an error. It's like, well, wait a sec. The 10.0.0 isn't even in your master subnet range. I go, oh, no, it's not going to. I'll say the first subnet is going to be 172.16. And I'm going to start it from 1. Because I want to save any confusion that you guys might have. I could start it from 172.16.00/24. That'd be fine. That would give me a subnet of 251 available IP addresses in the 0. But just to make sure that we don't have any confusion between the master subnet and the subnets, we'll go ahead and do that, right? From there, availability zone. Which data center in Virginia do you want this to be in? I would definitely pick it because you're in control of the subnetting. If you choose no preference, Amazon will just pick one for you randomly. They'll say, let's throw you over here, least amount of utilization over there. Subnet name, we'll just call it first subnet. Again, I don't like their reference of public subnet because it's not a public subnet until you make it a public subnet. Do you want DNS within there? This will essentially set up a DHCP option that allows it to use the Route 53 DNS servers for you. And you go, yeah. And then we say, do you want dedicated hardware or not? And I can say, okay, I don't want to pay a fortune, so I'll just use the normal EC2 instances that are shared by everybody else. Okay, create. So it's going to go through, and essentially it's creating every single element. You see those things whiz by? Every single element that was on the previous slide are created for me right there. So now it's laid that out for me. What's left? Well, to launch some EC2 instances into it, of course. I'm going to go over to the EC2 management section. Hit the instances, and we will go to launch instance. I've got an Ubuntu server right there. We'll use the free tier eligible. Hit next, and notice it automatically chooses this Meet Virginia VPC to put it into, and it automatically has chosen the first subnet of that. Now notice what's happened. It doesn't even let me launch them into EC2 Classic anymore. They're like, hey, you've gone VPC, you're not going back. Amazon really does want everybody in the VPC world. They're trying to phase out EC2 Classic just because of the great abyss feel that it has. Now you can see there's a lot of other options you can put in. Typically when you launch an instance, I'll just hit review and launch, and launch. CBT keys 9-1. I gotta make sure I've got that one. Please hold. Yep, I do. Okay, so I'm going to acknowledge it, hit launch, and now it's actually spinning an instance up into that VPC. Now, the last piece of this, now a lot of, AWS in all their glory automates so much stuff. One of the last pieces that was done was it actually created a security group for that EC2 instance. Now, it's still in the midst of spinning that up, so won't modify much of that process, but right there you can see the security group it created was Launch Wizard 1, which if we look at the view rules, this was an Ubuntu Linux instance, so it says I'm going to allow SSH from anywhere by default. We can go in and tweak that and modify it if you will. Matter of fact, one of the pieces to discuss was the security groups and network access control lists. These are available in the VPC. Let me jump back over there. Under the security section, you can see the network ACLs and the security groups. Security groups essentially apply on a per instance basis. Network access control lists apply to the subnet as a whole. Now, I want you to know this nugget right now is very wizardrific, meaning I'm showing you the VPC wizard, I'm showing you some of the stuff it does behind the scenes. However, there will be much more that we go into in one of the upcoming nuggets where I break down each one of these individual line items. I think I like that name. I think I'm going to call it the nitty-gritty of VPC, where we get into each one of these. But we now have, let's see if it's registered yet. We have one running instance, which is fantastic. However, that instance is inaccessible until we assign it an elastic IP. You can see right here, it's got a private IP address. Woohoo! Coming from our new subnet. They even take care of the DHCP for you, so it automatically assigns an IP address from that subnet. But I need to go in to the VPC and assign an elastic IP address, thus making it, as Amazon would call it, the one public subnet that we want to have. So I'll allocate the VPC, allocate the elastic IP address, associate that address with my instance. Now, you notice in the VPC land, one of the things you're able to do is associate that with a network interface. Now, that's pretty awesome because we can detach network interfaces from the instance and apply it to other things. I was mentioning this on the benefits slide a moment ago. For now, again, in the non-nitty-gritty nugget, I'm going to go in and say I'm just going to associate the public address with the instance. The security group is associated with the instance. By default, the network ACL, if you look right here, allows everything. They have it. Essentially, it's a access control list that applies to the subnet as a whole. But by default, all inbound and all outbound are allowed, essentially making it useless until I go in there and tweak it. For then, or I should say for now, it's just going to reply. I just need to stop speaking. It just relies on the security group, which is the one that defines the permissions. You can see there's our Launch Wizard 1 with the inbound rule of allowing SSH from anywhere. The last piece of this is, in my opinion, the most important, which is an understanding. Really, this nugget has been focused on what are the benefits of VPC. Here's a flyby on how to set up a VPC using the wizard. In an upcoming nuggets, I'm really going to slow down and spend some time into the nitty-gritty, even some of the line items we didn't touch from the previous slide, like routing tables and so on. But I want you right now to get a conceptual understanding of the routing in VPC. This slide is not something you'll find on Amazon Web Services. It's something that I've constructed myself to help the network guy or gal in you to really understand what's going on behind the scenes. When you create a VPC, you really create a big picture subnetting scheme that is applied to the region as a whole, to all the data centers that are there. Essentially designating that master subnet. In this case, instead of 172.16, I'm using 10.0.0/16. So essentially this becomes the network identifier. I then break that VPC into the individual subnets, which I just use the Amazon naming. When you just create a subnet, they by default name it public subnet. So we'll just say public subnet 1, public subnet 2. Even though it's not a public subnet, this is a private addresses. These are the individual private subnets that you can map to elastic IP addresses. I can tie those into an elastic IP address and make it a public subnet. Notice this is an availability zone 1, availability zone 2, or whatever data center you would like. You can put multiple subnets into an availability zone and attach instances to each one of them. It's however you want to do it. The missing piece from a lot of AWS documentation, that's one of the, I want to say challenges like it's a big deal, but one of the challenges of AWS is they automate everything so well and so like, oh yeah, just hit this button and look, it's all working, that it almost takes out a lot of the, well, okay, really, how does that work? I mean, because you lose some of the behind the scenes, how it's working in the ease of use, which you can totally see why Amazon does it the way they do. But essentially what they are doing when you create a VPC is they are bringing a router into the picture. How they do that? Let that be the Amazon mystery. Let that be the, well, they're doing something with a Linux instance or a layer 3 switch or something. They're doing something behind the scenes. But they're introducing a router which allows you to communicate between your public subnets. Now, by default, the public subnets have access to each other from a routing perspective. I know this was one of the questions I asked on the do I know this already slide. From a routing perspective, I'm going to introduce this other element right here called the routing table. Essentially, every single one of the subnets have a routing table saying here's what you know how to reach. And every single one of the subnet has access to essentially the VPC. So this is saying, you know, this routing table is applied to the subnets, and you can see right here is the subnet that we created. Its routing table is this RTB blah, 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 blah. It's essentially saying this subnet, first subnet, can reach 172.16.0.0/16. So it knows how to, from a routing perspective, get to everything. However, we have security groups and network access control lists which restrict that subnet. Right? So at the router, this is where the NACL applies. So as you go from subnet to subnet, and you also have on the EC2 instance itself, the security group. Just because you're part of the VPC, just because you're under a managed subnet does not give you the ability as a machine to just punch right through a security group. No, no, no. You still go through the NACLs. You still go through the security group filtering and all of that. So when you're going from subnet to subnet, from a route perspective, you'll know how to get there. But you may not have access to get there, right? This router is also what introduces you or allows you to access the VPN connections, one of the other line items on this list, allowing you to get out of the Amazon space into another data center or into your own on-premise equipment. Attached to that is the internet gateway. When you spin up the instance, it automatically creates this internet gateway, which is a redundant device by itself. Essentially, it's the gateway that Amazon uses to get to the internet, but they assign that to you. And so let's start tying some of these pieces together. Check it out. I look at the routing table for this subnet. It says, I know how to get to everything 172.16.0.0, and I know how to get to 0.0.0.0. That's a nice broad route that says, this is anything that I don't know about will end up going to the internet gateway. So I know about 172.16 routes. Anything else, I'm sending straight out to the internet gateway and going from there. If I start adding VPN connections, we'll start seeing routes appear in this list of all the different destinations that we put this subnet to have access to. So that's what the routing table is. See, I told you I'd fill in some of those cracks. So this router allows you to get out of the VPC space, allows you to go to a VPC peering connection, which wasn't even on my list, but you'll see it here in the web interface. A VPC peering connection is another VPC. Like, let's say we set up another VPC in this region, or maybe even under a different account, we create another VPC for billing purposes or something like that. You can actually tie the VPCs together through this VPC peering connection. I've said VPC a lot. Does this picture help? It kind of gives you the big picture of how it all ties together. Oh, except for, I didn't mention this. What about those guys in EC2 Classic? How do they get to your VPC? They don't. Or rather, they get to it the same way the rest of the world does, through the internet gateway. Amazon really, I can almost feel 15 different boardroom meetings. How do we tie together this thing that we created we now call it EC2 Classic, but that was how we started AWS. How do we tie that together with this now managed subnet world of VPC? And after 15 boardroom meetings, they're like, we don't. You can't, because you can't go into no man's land of EC2 Classic, of private addressing gone wild, and bring it into a managed addressing, because what about the overlap? How do you manage? So anyway, you can see the challenge they had. And so essentially, they are cutting off EC2 Classic in favor of VPC. Maybe even by the time you hear this, there's no such thing. You're like, Jeremy, what is this thing called EC2 Classic? I've never heard of it. Maybe by the time you're hearing this, there is no such thing as EC2 Classic, because Amazon is on a mission to make that go away. I know this is a lot of information. It's almost like jumping into the VPC swimming pool and we're like coming up for air after this swamp of information was just dumped on you. Don't worry. I had planned on this being like the welcome to VPC. Let's get our feet wet and a little bit more. In the upcoming nuggets, we're going to start breaking VPC down, looking specifically at those routing functions, kind of the subnets that I clicked on in the routing tables and the internet gateways. I like, oh look, oh look, oh look. We're actually going to spend some time looking into each one of those, as well as a whole nother nugget on the security provided in VPC, understanding those security groups and network access control lists. For now, we have seen a big picture overview of the benefits, the initial VPC setup, walking through the wizard, as well as understanding how VPC does its routing. I hope this has been informative for you, and I'd like to thank you for viewing.